Hi, everyone, and welcome to the first lecture video for EG1311 Design and Make. My name is Dr. Jason Koo, and I am a senior lecturer in the Department of Mechanical Engineering here in the College of Design and Engineering. So this is a core module within the College of Design and Engineering that falls under the makerspace pillar, which really just means that it's centered around you having a hands-on project-based introduction to engineering. And more specifically, you're going to be building and designing a robot to traverse an obstacle course that brings together a whole lot of different components of engineering and just introduces you a little bit to each one of them. So what are the learning outcomes for this module? Well, first off, it's some soft skills of teamwork and learning how to communicate and provide communication deliverables and ideation and prototyping and design. Some of those kinds of soft skills that are going to be useful no matter what discipline you're going into in the future. And then there are some harder technical skills that we emphasize in this class, namely on the mechanical side, some mechanical design workflows, how certain things are fabricated. You're going to get access to manufacturing using a laser cutter at some point during this module. But really, it's going to be the mechanical design part of it is going to be centered around teaching you a little bit about CAD software, computer-aided design software, namely Fusion 360, which you'll be using to design and communicate mechanical parts that you design. And then lastly, some technical skills of electronics, programming and wiring and dealing with the circuitry of a little microcontroller called an Arduino, and learning how to control sensors or talk to sensors, control motors, things like that, in order for you to accomplish the goals of this robot on the obstacle course. So hopefully all of you have found this video through our Canvas site. And so this is our website and will be our communication mechanism for you during this class. Now, as some of you may have already realized, that it's possible to get a lot of notifications by email and push notifications and things like that on your phone. Hopefully that will be minimized throughout the term. We will only be pushing content to you via announcements like the one that you had at the beginning of this term, but you are able to set your own notification settings at both the account level and at the course level. So you can modify those as you'd like to get notifications as frequently or as sparsely as you desire, but keep in mind that you are responsible for any of the communication that we send via the announcements interface on Canvas. And so if you're not set up to receive those notifications for official announcements for the class, you are still responsible for the material and the deadlines that are announced via that mechanism. So please make sure that you're receiving those notifications so that you don't miss anything important. Right now, the front page of this site is pretty bare bones, but it will be fleshed out over the course of the coming weeks whenever we have some new information for you, and we'll have a summary of what you need to do each week in preparation. So that's the Canvas module for this class. Now moving on to the staff who will be helping with this module. There's, of course, me, the lecturer, who will be delivering to you all the lecture content, but we also have laboratory staff members who are in charge of keeping that lab space for you. And in particular, Mr. Vincent will be there to help you during lab sessions in case you have broken parts or if you have questions about using any of the tools in that lab while you're there, they're the ones to ask about that. Then we have faculty tutors. One of them will be in each of the sections that we have during the term. So they're your point of contact. They're from across the spectrum of engineering backgrounds within the College of Design and Engineering. And so they're your resource in case you want to talk to a faculty member about engineering and their particular specialty. But we also have in each section 2 undergraduate TAs. These are all students who have taken this module in one of the recent semesters. And they're there for if you are having a lot of trouble debugging something, they're going to be the ones helping you cut parts on the laser cutter, for example. So they're really your good technical resources for the nitty-gritty about what's going on in your project. Down here on the bottom, we have a schedule of all the different labs that we have. We have 24 laboratory sessions, which each meet every 2 weeks in the E40206 laboratory space. We have lab sessions every day from Monday to Thursday, 9 to 11, 12 to 2, and 3 to 5 every day. We don't quite have enough lab space available for you guys to attend the lab every week. And so what we have are all of the odd numbered sections meet on odd weeks starting in week 3. And all the even numbered sections meet on even weeks starting in week 2. So actually the even weeks will start before the odd weeks in terms of their tutorials. And you can see down here the listing of all of the faculty associated with those sections. Now, there is no tutorial sections happening this week. Those tutorial sessions will not even be allocated into the end of week 1, and we'll be assigning you teams within those sections the weekend before week 2 begins, so next weekend. So that's sections, that's all the staff that's going to be helping us out. Feel free to ask questions. The lab time is your time to ask questions and to take advantage of the fact that you have your seniors as well as faculty members there for in-person help. Okay, here is a brief course calendar of what all is going on in this module from weeks 1 until week 13. As you can see, there's no tutorial that will be given in week 1. But we do have lectures starting in week 1. And in particular, we are releasing 4 lecture videos this week on week 1. And lecture videos we'll discuss on the next slide, but we expect you to have those watched and completed within the week that they are released by Friday. We'll get to that in a second, what those exact deadlines are. But in general, the first week we'll have introduction to the project and lab safety and things like that. Weeks 2 and 3, we'll be talking about Arduino and electronics and programming and things like that. Weeks 4 and 5, we'll be talking about CAD, using Fusion 360, making files to submit to the laser cutter, for example. And then we'll talk a little bit about design in week 6. Now, that'll bring us up to the recess. And after the recess, we won't have any lectures. There will be no more lecture videos for you guys to watch. You'll just be concentrating on working on your robots. We will have 2 evaluations, individual evaluations for you on the kind of technical hard content that we have presented in weeks 2 to 5, namely an Arduino quiz on the lecture content that was covered in weeks 2 to 3. That'll be on Friday, October 2nd. And then the CAD quiz on the material that's covered in weeks 4 to 5, that'll be on Friday, 16th October. So keep those in mind. Just make sure that you have some free time available during those days so that you can take this quiz. We'll get to the details of those quizzes in just a second. Then in parallel with all the lecture content and these assessments, you have your tutorials going every other week, right? So tutorial 1 will happen in week 2 and 3. Tutorial 2 will happen in week 4 and 5, depending on whether you're in an even or an odd section. And so every section will have 6 tutorials. And in the last tutorial, you'll be submitting, right before tutorial 6, you'll be submitting a paper and a video file that will kind of wrap up your team's contribution to this project. And you'll be presenting your videos in tutorial 6 so that other students can evaluate how well you and your team did on the project. So that's what's happening in tutorial 6. That's the course calendar in a nutshell. Let's go into some specifics on each of these different components. First, we have that course structure. We've got the lecture videos, the tutorials that you have to attend in person in the lab E40206, the 2 individual quizzes on the Arduino and CAD materials, and the team project where you'll get points for running your robot on the obstacle course, and for submitting your team report and video. Lastly, there's a peer review portion of it where you'll get to rate the videos of your peers within your section, as well as be able to rate individually the other team members within your team. So there's two different types of peer review there. Down at the bottom here, this is a breakdown of all of the graded components and their weighting for this class. 45% of your grade is allocated to your entire team. It's the same across your team, with 10% for your robots run on the obstacle course, 10% on the report body and appendix respectively, 5% from an outside tutor on your video, and 10% from your external peer review from the other students in your section. And on the individual side, 55% of your grade is individual, how you perform as an individual. 10% is on you viewing these lectures, so making sure that you're completing viewing those lectures. The Arduino and CAD quiz, which are 15% each, and then the two peer reviews, which constitute 15% total of your grade. We'll have a midterm review that needs to be submitted during the recess week, and then a final one, which will occur once you're completed tutorial 6. Detailed rubrics for how all of these components will be graded are posted in the course information handout, which is a 7-page document with more information than you possibly want to know about this course. That's posted under the files section of Canvas. So please go there if you have any questions about this course, or of course you can send us an email to ask, but we'll likely redirect you to that PDF in case the information is there. Now for the lectures, again, we have the introduction lectures this week, the Arduino technical lectures in week 2 and 3, the CAD lectures in 4 and 5, and some content on design and teamwork and things like that in week 6. Videos will be posted at the beginning of each week. This week, we're posting on Monday morning. They need to be completed, watched by 5 p.m. On Friday, the same week that the videos were released. So you need to be completed watching all of the lecture videos for this week by Friday at 5 p.m., including little in-video quizzes that we'll be putting within the videos. And if you don't interact with those in-video quizzes, then we're not going to give you credit for having watched the videos. So you not only have to watch through the videos, you also need to complete the quizzes that are either dispersed throughout the video or located at the end of the video. So on-time completion of these lecture videos is worth 10% of your grade, and it's a relatively easy thing to do. So I would suggest actually watching the videos, keeping up with those things. It's an easy 10% of your grade. There are also optional Q&A sessions with me every Friday. These are live sessions over Zoom at 9 a.m. on Fridays. I know it's pretty early, but that's when the scheduling office found is a good time for dealing with a class of this size. And so that's a great place for you to ask technical questions about your content or about anything that I've covered in the lecture videos. If you have any questions, please go to the discussions section of Canvas. And it's a lot better when you ask your questions publicly on the discussion section of Canvas so that other students can benefit from our responses to your questions. But if you're uncomfortable with that format, you're also welcome to email us or message us individually through the Canvas website. Okay, on to the quizzes, the individual quizzes. These will be occurring in weeks 7 and 9, right after the recess. And these quizzes will be conducted online within an 8-hour period on each of those Fridays to be able to complete this 45-minute multiple choice quiz. Okay, each of these quizzes will have randomized questions, so you won't necessarily be getting the same set of questions as the other members of your team, for example, but you should be getting similar questions. They just won't necessarily be exactly the same. You'll have an 8-hour period of time to start that quiz, but make sure that you allot some time during that day to be able to complete it in a room by yourself without any distractions so that you're not tempted to communicate with anyone. So it is open notes. You can use any of the static resources that we're putting on the website, or, if you want to look up an ASCII table online, or if you want to, model something in Fusion 360, or you want to play around in Tinkercad. All of those kinds of things are allowed, But what you can't do is talk to another person, either digitally or in person, during the evaluation, because that would be dishonest. That's against our academic honesty policy. So I would request that you guys don't put yourself in a situation where you would be tempted to communicate with someone. We have had instances of students, trying to do the quiz all together at one of the benches in the engineering. And I've walked past them while they're in the middle of doing their quiz and they're talking to each other. That's not good to do. And those students were punished for that. And we don't want to have to give you a 0 on 30% of your grade because you decided to act dishonestly. So please don't. The quizzes will be multiple choice, fill in the blank, and we'll give you similar types of questions in lecture videos so that you can have a sense for the format. Okay, so that's the quizzes. I mentioned the use of Fusion 360, which is a CAD software during those quizzes. We actually have 3 software that you will need to use during the course of this module. One is the Arduino IDE, which is IDE stands for Integrated Development Environment, which is basically the way we will code and program the Arduino microcontroller from your laptop. So you'll need to download and install that software. It's cross-platform. You can get it for a Windows or a Mac or even a Linux system. Tinkercad is an online electronics simulator. You don't need to download any software for this. You just access it through the browser, and you'll just need to make an account so that you can tinker with electronics virtually, as opposed to spending a lot of time doing that physically. You can plan that out in Tinkercad before you implement it in real life. And then the last software you'll use is Fusion 360. You'll need to download and install that on your machine. There are instructions posted on Canvas about obtaining Fusion 360. In particular, there are a couple different licenses that you can get. You can get a personal license, which has some restrictions to it and is limited time. But all of you as NUS students will be eligible to apply for an educational license, which has many fewer restrictions and allows you to use it throughout your time here at NUS. And so I would suggest you all apply for that, but actually the personal license for the purposes of this class will be good enough. So Fusion 360, also cross-platform, works on a Windows, Mac, or a Linux system. Okay, so that's the software in a nutshell. Let's talk a little bit about your project. Each of you will be put on a team where you will need to build a little robot with the materials that we've given to you to traverse an obstacle course. It will go from one end of a table in a starting area, a 30 centimeter by 30 centimeter by 30 centimeter cube, move forward outside of that cube volume, go over a small 3 centimeter hump, traverse over a ramp that's 10 centimeters tall, and then to reach this wall that's in the middle of your path. And the goal will be to reach the wall without touching it and to deliver a ping pong ball from the starting area and to deposit that ball over the wall without touching the wall. So, right, your robot must start within that volume. If it cannot fit within that 30 centimeter cube at the start, then we won't even allow it to run on the course. So it's really important that you're not violating this volume constraint, this size constraint. You begin in the starting area with a ping pong ball, you traverse over the obstacles to reach the wall, and the goal is to stop close to the wall within 5 centimeters, but not to touch it. And then you deploy the ball over the wall, again, without touching the wall. And to be even more specific, here's the grading rubric that we have in the course information handout on Canvas. There are 10 points that you're eligible to get that are somewhat independently assignable from each other, though some points are not possible to get unless you have achieved some other points in the rubric. For example, the first point indicates that your robot passes the bump, whereas the second point indicates that your robot passes the ramp. Now, clearly, since the ramp is past the bump, your robot can't get that second point without getting the first point. Alternatively, one of these rubric items is that no part of your robot touches the wall. And that will be true even if your robot never passes the bump. So you will be eligible for that point, even if you don't pass the bump. So it's very difficult to get 0 points on this obstacle course. Now, the first 7 of these rubric items are the base points that we hope all of you can achieve by the end of tutorial 5. Then if your robot achieves all 7 base points, then it will achieve 1 additional weight point if it is not the heaviest among all the robots that achieve those 7 base points. And it'll achieve another weight point if it is the lightest robot in your section from among all the robots scoring all 7 base points. Not only is weight an optimization that's easy for us to test, it is also a common engineering constraint in other situations where lower weight often goes hand in hand with things like lower material and manufacturing costs. Lastly, as an added goal above and beyond the base objectives, your robot can also achieve a bonus point if it completes all the base points and then returns back behind the bump without falling off the course. After the robot goes back behind the bump, it can fall off the table, or you can stop the robot yourself or pick it up. It just needs to get back behind the bump on its own without your interaction for you to get that bonus point. Okay, so here's a breakdown of how that project will be accomplished via your 6 tutorial sessions. In the first tutorial session, you'll be tasked with first signing a safety form that we'll be going over in a lab safety video after this video this week. You'll receive your parts, kits, and make sure everything's there. But once you've confirmed that you've received all of the parts that you're supposed to have, then you'll be tasked with putting together a robot we've designed for you, which I call the template project, that will just show you all of the components working together to move and interact with its environment. And so you'll see an example of that robot running in a later video this week. However, you won't necessarily be able to fully complete that robot at the end of your tutorial 1 because you won't necessarily have watched all of the videos when it comes to electronics to be able to understand how everything should fit together. But some of you will be able to finish the template project in tutorial 1, but the hope is that by the beginning of tutorial 2, your template project will be completed and you'll be able to move on to brainstorming and prototyping for your real robot to traverse the course. Now, the template project we give you purposefully is a pretty crappy robot, right? It doesn't get over the 2 obstacles that are in the way of your wall. It doesn't stop the right distance from the wall. It can't even really carry a ping pong ball. So you'll have to, starting in tutorial 2, you'll begin working on that process of how can I change and adapt the template project robot into a robot that's going to be able to get 10 points at the end of the term. Okay. In tutorial 3, your immediate goal is being able to get your robot to the wall, right? Getting it over those 2 obstacles. Because if you don't get your robot over those 2 obstacles, then it's really hard to get points associated with the ball because, some of those points mean that you have to bring the ball past those obstacles. And so there's not really a lot of point in working on your ball release and delivery system unless you can make it to the wall. So that's your priority in tutorial 3, prototyping revisions, developing a work in progress prototype that can reach that wall. In tutorial 4, you're doing more refinement and testing, and this is the point where you should be working on that ball delivery mechanism to reach an almost finished, nearly finished prototype. You'll have a finished prototype in tutorial 5, and tutorial 5 is where you'll do your graded runs on the obstacle course. You'll have 3 tries to run your robot on the obstacle course, and we'll take the max score out of any of those 3 tries. And then if you're done early in that tutorial time, you'll have some extra time to work on the video and the paper, which you'll have due by the start of tutorial 6. In tutorial 6, we'll have a wrap up for the course. That's the point in which you will dismantle and return all of the parts in your parts kits that you received in tutorial 1, and you'll present your videos to the rest of the class. And we could just have everyone just watch all of each other's videos online, but having you there to present your videos also allows us to have a Q&A so that you get some practice with in-person communication in presentation as well. So that's the tutorial schedule that we have. Attendance at those tutorial sessions, those laboratory sessions, that is mandatory for this class. Really, this class is mostly about your in-person experience in the lab, your hands-on maker, space experience in the lab. And so if you have to miss a substantial number of laboratory sessions, then unfortunately, we're going to have to ask you to take this course in another term, because that's really what this course is all about. It's also unfair to your team if you're not there participating in person with the other members of your team working on the project. So do let us know if you have an issue. If you have a medical issue, for example, that keeps you from coming to lab, we can give you an excused absence. But if you have unexcused absences, then we reserve the right to lower your team component grade based on your absences and your peer review. If you get very low peer review feedback, for example, then if you haven't been attending and participating, and your teammates also tell us that you haven't been attending and participating, then you should not have access to the 45% team grade associated with your team. And so the details of that are outlined in the course information PDF. It is important that you attend your assigned section, because that's where your team is. It's not super helpful for you to attend some other section as makeup, because your team won't be there, your parts won't be there, and so there's really no reason for you to be there. Now, keep in mind that you only have 6 2-hour sessions, in actuality 5 2-hour sessions to complete your robot, because the 6th one is for presentation. So it is expected that you'll need to spend time outside of the scheduled lab sessions to work on this project. This is a project that will take some time, and we don't have lectures on the second half of the module for the fact that we know that you're going to use a lot of time outside of lab to work on your project. Teams are expected to meet outside of the lab on their own on off weeks for about 1 to 2 hours. I would suggest that you meet during your regularly scheduled lab session on the off weeks when you're not actually going to lab, because that's a time when probably most of you are available. The nice thing about the parts kits that we've given you is that pretty much anything that you can do in lab, you can also do outside of the lab. And so we make it very easy for you to do work on your robot outside of the lab. You'll notice that we only have tutorials on Monday through Thursday each week. Fridays are a free day. And so you may reserve lab time on Fridays, come in. You just have to, the procedure is you have to let the lab staff know that you're coming in advance so that we can make sure that there's availability for you. If you come without sending an email and arranging it in advance with the lab staff, we may not be able to accommodate you when you get there as a walk-in. Okay, so that's extra time on the project. Now I'll talk a little bit about the team report and body and things like that. So the team report has 2 components: the body, which is like prose, report, description, documenting your team's journey through the project. It'll have a full summary of lessons that you learned through the process and difficulties and how you overcame them. And that's limited to 5 pages of text, 12-point Times New Roman font, single-spaced. And that doesn't include things like the title page, the table of contents, the appendix. That's not included in the page limit, but that's really the limit on the amount of text that you can provide. Versus the appendix, which doesn't have a page limit, but really should not have any text. It shouldn't have any prose, except for maybe figure captions and things like that. Basically, what the appendixes are blueprints for your final robot, documentation on how to reproduce your robot. A lot of what engineering is doing work that then can be confirmed and reproduced by someone else. And that's what this appendix is for, is to provide that kind of documentation so that if I gave someone your report, they'd have enough information to be able to produce your robot and repeat your results. So what the appendix needs to include is a photograph of your final robot, a 3D CAD rendering of your final robot. And those are to kind of help us know how the parts should be assembled if we wanted to build your robot. A Tinkercad of the electronics on your final robot. So it's basically a wiring diagram of how everything is hooked up physically. The Arduino code for the software that's running on your Arduino when it ran on the course. And 2D CAD drawings for each component that you cut out of the sheet material that we're going to give you. We're going to give you a bunch of raw material like cardboard, polypropylene. You'll have access to acrylic to laser cut, things like that. But these are all sheet materials, so just flat, constant thickness boards. And what your job is in this appendix is to document all of the parts that went onto your final robot, how you cut those parts out of the sheet material that we gave you. Now, if you modify those parts after you cut them out of the sheet material, like folded up the cardboard or something like that, you don't need to show us how you modified it afterwards. You just need to show us the cut pattern of how those things were cut out of the material, the flat model. And so we'll be talking about that more when we get to CAD drawing and things like that. Now, the video has a different purpose than your report. The report is really to kind of document your journey as a team and how someone else could make your robot at some other time. That audience is the tutor for your section, right? The person who's been with your team throughout the 6 tutorial sessions. They're the ones that are going to be reading and providing you a grade on your report. The video, the audience for that will be the other students in your section. They'll be providing 10% of your grade for how good your video is, whereas 5% of your grade, some other section's tutor will be grading your video. They'll be looking at your video. So in general, the people who will be looking at your video will not be familiar with your robot or anything about your section or anything like that. This should be thought of as, you're showing your journey of the project, but also highlighting what makes your robot different than other robots that are accomplishing the same things. It should be a little bit more entertaining than the report. It's not as comprehensive as the report. It should just be highlighting one difficulty that you overcame. And another requirement is that it provides video of the final robot on the course so that we have documentation that your robot was actually able to perform on the course, even if it didn't get the full 9 or 10 points. The video can't be more than 5 minutes long, but it can be in any presentation format that you like a TED Talk, or, include animations, or any format that you'd like on the video is fine. I would suggest adding captions because it can be difficult sometimes with the audio in the lab space to hear all of what you're saying. And so captions can be really helpful in delivering the content that's in your video to the observer. Okay, so those are the deliverables. The last graded component for this class is the peer review, which will have 2 individual internal peer reviews of the rest of the members of your team, one during the recess break and one at the end of the module after tutorial 6. And that's where you're rating the other members of your team based on their attendance, their contributions, their communication. Generally, even if they're not the most technical contributors to your team, if they're attending, they're participating, those kinds of things, they should be eligible for a pretty good internal peer review. The external peer review, that's you grading other teams within your section, grading their video at the end of term. And there, you're grading them on the creativity of their ideation, the effectiveness of their communication of their video, and how well that robot differentiated itself with respect to creativity and things like that. So that's an overview of the course and all the graded components of this course. Please stay for a brief quiz, multiple choice, at the end of this and every lecture video.